we're going to look at these problems over here about how to find the area. Excuse me. Because of the special relation between definite integral and the area, so we can actually solve all these problems. So let's first sketch the diagram of the function. Okay, the function f of x is given over here. So you can actually just roughly sketch the diagram. It says between -2 and 2, we have square root of 4 minus x squared, which is just a semicircle. And between 2 and 4, we have the function, it's 4 minus x. So when x is 4, it's 0. When x is 2, it's going to be 2. So what we have is something like this. Okay. And here is discontinuous. So here we don't have really a value. Okay. Now we are ready to find these integrals. So look at the first one. This one over here is the area between 0 and 4. So between 0 and 4. And bounded by function and also by x-axis. So this is x-axis, and this is y, or f of x. So this part over here, let me just sketch the diagram again. So this is between 0 and 4. And here we have semicircle, and here we have this. Okay, so we have over here a quarter. It's a quarter of circle, pi r squared, and plus a triangle, the area of a triangle. So now if we write down the total area, this is going to be 1/4 pi, and r is 2 squared, and then plus 1/2 base is 4 minus 2, and height is also 2. So that is the answer. So we have pi and then plus 2. All right. So now let's try between 2 and 4. So between 2 and 4, we just have a triangle over here, right? So we will simply have this integral over here is simply going to be half base times the height, and that's going to be 2, and then this is 1/2, 2 times 2, that's 2. Okay. Now, number 3 over here involves so-called the linearity, and this definite integral is going to be equal to from 0 to 4, 3 dx, and plus 2, you can see, just integrate inside, so it's called linearity, and f of x dx. Now this one over here is a rectangle. This one over here means that we have 0 and 4, and here we have 3. Okay, so this is a rectangle. So this part over here is 3 times 4. And this part over here, we already computed. So this is 2 times pi plus 2. And that would be 12 plus 2 pi plus 4. So this answer over here is 16 plus 2 pi. All right. And we can see this is pretty fast to do this. Okay. So let's try to see if we can look at this problem, number 4. Now, we are a little bit unsure about what f cubed x is going to be, because it's going to be a complicated function. It's unlikely that we can find its definite integral using the area. But on the other hand, we notice that over here, we have integral from 2 to 2. That means we don't really have an area. It's just one line. So any function over here we have, it doesn't really matter over here dx. This is going to be equal to 0. So number 4 over here is simply going to be 0. How about number 5? So now we look at the upper and the lower bounds. We look at it over here. Usually we have lower bound is smaller than the upper bound, but here it's just the opposite. This is just a notational problem. So we know that this kind of integral over here is equal to negative. Doesn't matter what you have over here. You swap the upper and the lower limits, and the same function over here you have dx. Now this part this part over here is just the area of the circle, but it's semicircle, so we have negative 1/2 pi r squared, and that's going to be negative 1/2 pi. R is 2, so we have 2 squared, and that's going to be negative 2 pi. All right, let's pause over here